Hi everyone, welcome to my channel, Math Made Easy with Terry in 10 minutes. Okay, so we're going to talk about how to graph a cubic function. But before we do that, the first thing I want to do is to give a quick overview about a cubic function, because I know some of us have not encountered cubic functions before. Before I go in, please make sure you subscribe. Make sure you click on the like button. And if you have any question, please do let me know. And don't forget to click on the notification bell. So when I post new videos, you'll be the first person to know. All right. So a cubic function has the form of ax cubed plus bx squared plus c, which is usually the standard form, okay? So I'm going to be writing because I know some of us take notes from my videos. So a cubic equation or a cubic function, okay, has the form. So this form is what we call the standard form, okay? So has the form of what? Ax cubed, okay, plus bx squared plus cx plus d to be equal to 0, okay? So it has this ax cubed plus bx squared plus cx plus d equal to 0, okay? Now, here, the a represents the cubic coefficients, okay? The, the a represents the cubic coefficient. The b represents the quadratic coefficients. The c represents the linear coefficients, okay? And while the d is equal to the constant, and some textbook we call it the free term, okay? So you can see constant, you can see free term, it means the same thing. But you need to understand for anything to be cubic, okay, a must never be equal to 0, okay? So a must never be equal to 0. That means that there must be a value for x cubed. So a can be 1, a can be -1. There must be a value because when a is 0, it has turned to a quadratic equation. So I'm going to write it down so that you will not forget. So it must have the cubic function, okay, must have the x cubed term, or we can say the term in x cubed, okay? The cubic must have a term in x cubed, or it will not be called cubic, all right? Okay, so, or it will not be called cubic, so that means A must never be equal to what? 0, okay? But B, C, and D, okay? But B, C, and D can be 0. So you can have, for example, you can have something like 2x cubed plus 5x plus 7. Are you seeing it? In this case, x squared is what? 0. You can have something like maybe x cubed minus 5x squared plus 7x. This is also a cubic function. That means the free term here is 0, okay? So all these are forms of what? Cubic functions or cubic equations. Now, all cubic equations can either have one real root or three real roots. Okay, please, if you've not reviewed my quadratic equation, okay, please go back and talk about and look at it. Where we talked about real roots, we talked about real and equal, where we talk about the discriminants, okay? And we talked about so many types. So having that idea will make you appreciate the cubic equation. So all cubic equations, so all cubic equations you're gonna have will have either one, you can have one real root, and number two, you could have three real roots. So that means when you are having a cubic equation, you must have at least, that's what we're trying to say here, you must have at least one real. Okay, you must have at least one real. So because of, just a reminder, so if you remember quadratic equation, I told you quadratic, just a reminder, just to remind you. For quadratic, I told you a quadratic equation is in the form of ax squared plus bx plus c. Is that making sense? So, but a cubic, okay, just what we just talked about, a cubic is a little bit different. So a cubic is in ax cubed plus bx squared plus cx plus d, okay? So you can see that they look the same, but they are different. A quadratic equation, here, the highest power of x is 2, but in a cubic, the highest power is what? 3, all right? So what I want to do quickly is that I want to now let us see the difference between a quadratic and a cubic. Okay? So I want us to see the difference between a quadratic and a cubic. So I'm going to first start with the number of roots, okay? The number of real roots you can get. So I want to compare the number of real roots you can get in a quadratic and the number of real roots you can get in a cubic equation. Now, when you have a quadratic, okay, for quadratic, if you remember when we talked about the discriminant, what we said it's equal to the b squared minus 4ac. What I told you there is that you can have up to, okay, you can have up to maybe 2 real roots. Okay, so you can have up to 2 real roots. So you can have 2 real and distinct roots, okay, or you can have equal and distinct roots. Is that okay? But in a cubic is a bit different. Cubic is that you have up to, so you can have 1, 2, or 3. So you can have up to 3 real roots. Okay, so for cubic you can have up to 3, but in quadratic you have what? 2. Now, in terms of the solutions, okay, so I'm going to look at it in terms of the solution or no solution. So remember in quadratic, there are some questions you will have where you say no solution, right? Where you talk about technically real solution. So when I talk about solution, I'm talking about real solution. So in quadratic, if you remember the video we talked about, it's possible that you may have no real solution. Okay, while in cubic, you always have a solution, at least one. Okay, so you must always, the key word is always. You can't have no solution. Always have at least one solution or one real root or one solution. So I'm going to just say one real root so that it will make more sense to you. Okay, or one solution. All right. Then number 3, one of the things I want to talk about to explain quadratic and cubic is that in terms of repeated solution, so you can also notice as well that you can also have this in terms of repeated solution. Okay, so in quadratic, what you will notice as well is that when you have quadratic equations, you can have both solutions can be repeated. Okay, you can have 2 solutions repeated. Okay, so you can have x is equal to 2 twice, okay, in this. But in cubic, that's not the case. In cubic, you can have the whole 3, okay? You can have all 3 solutions what? Repeated. Okay, so you can have all the three solution what? Okay, so I've talked about quadratic and cubic. So in terms of the number of real roots, in terms of either it's quadratic or cubic, or in terms of solutions or no solutions or the repeated solutions. Okay, now what I will talk about now is that cubic functions, there are some important notes I want you to keep in mind before we start, okay? There are some important notes on cubic function I want you to know, all right? So the important notes about cubic functions. Okay. The first one is that a cubic function is always in the form of ax cubed plus bx squared plus cx plus d. I've said this before, but I'm just going to write it here so that you will just to reiterate it so that you won't forget. So a cubic function is in the form or is of the form. We have f of x is equal to ax cubed plus bx squared plus cx plus d. So in this case, where a, b, c, and d are what? Constants, okay? So I've told you, and also I also emphasized as well, that a can never be equal to what? 0, okay? And I told you that a is a cubic function, quadratic function, linear coefficient, sorry, and a free term. We talked about that earlier. Number 2 is that the degree of the cubic function is 3. All right, so when we talk about the degree, we're referring to the highest number of x, okay? So the degree of a cubic function is 3. So that means you can never have the highest power of x, okay, to be less than 3, okay? So that means you should always have it to be 3, okay? That's what we call a cubic function. So number 3, like I said earlier, a cubic function may have 1 or 3 real roots, okay? You can have more than, but it's going to be between 1 to 3 real roots, okay? Now, number 4 is that a cubic function in terms of the complex roots, a cubic function may have 0 or 2 complex what? Roots. Okay? So you might have no complex roots or you can have 2, but it's not possible for you to have 3 complex roots because we said you must have in a cubic function they must have at least 1 real root. Okay? We'll talk about this soon, which will help us in sketching, is that a cubic function is maximum or minimum at critical points. Okay? So a cubic function has both a maximum and minimum, okay? But it's maximum or minimum at critical points. Okay? So we have that. So those are the 5 things I want you to keep in mind. So a cubic function has a form of ax cubed plus bx squared plus cx plus d. The degree of a cubic function is always 3. The cubic function may have 1 through to 3 real roots. A cubic function have 0 or 2 complex roots. A cubic function is maximum or minimum at complex point. All right, so before we go straight to sketching, all right, I will have to talk about 2 things, okay? Now, for cubic functions, I won't talk about how to factorize and solve because it's going to be important for us to sketch. You need to know how to find the x and the y intercept, okay? I need to know how to factorize the cubic functions. And I'm going to talk about the different ways on how to factorize, because it's very important. So, because when you are given a cubic function to sketch, you need to know how to factorize it so you can get the x-intercept. Is that okay? So I'm going to show you how to factorize it. Then when we're done factorizing, then I'm going to go straight to what? Sketching. Okay? I'm going to go straight to sketching a cubic graph. So the next video we're going to talk about is going to talk about how do we factorize and solve a cubic what? Function. Okay? The next video will be how do we factorize and solve a cubic function. Okay? And that'll bring us to the end for this video. So I believe by now you should have a pretty much good idea of a cubic equation or a cubic function and how it compares with a quadratic what? Equation. So I'll see you in the next video. Please, if you've not subscribed, you've not clicked the notification bell, please do so. So when I post the next video, you'll be the first person to know. So see you soon.